Okay, gang, here's part 2 where we look at the week 8 written assignment and just give you a few hints. In part 1, you've got 3 functions presented here. H of x is given in the usual way with a formula, but f of x is given just with a graph, and g of x with a table. So all you get for g of x are input-output pairs for a few inputs. Okay? But then you go through here and you find something like, let me come down here to this first composition. It's actually written f of g of 3, but that's of course f composed of g of 3. For any composition you're going to start on the inside, so figure out what g of 3 is, and for that you go to the table that defines g, and you go to the input of 3, and the output g of 3 is negative 2, so that means this is f of negative 2. And then worry about the outside function. So now that we've figured out that g of 3 is negative 2, we want f of negative 2. Here's what defines f, this graph. And when you input negative 2, that x value, you find this point on the graph, this ordered pair negative 2 comma negative 3. That's the output. When you input negative 2, you get negative 3 out, right? The y coordinate associated with the x coordinate of negative 2 is negative 3. So that's how you find f of g of 3. Here's another composition. Here's a product. So this is just f times g of 2. You just find f of 2 and g of 2 and multiply them together. Let's see another composition here. I think I'll go on to the second page because actually this starts to get a little more nasty where we see inverses. So page 2 looks very similar. Same 3 functions defined the same way. But we've got some questions like, is f 1 to 1? Yes, because the horizontal line test is passed, right? It's a function because of the vertical line test. It's 1 to 1 because of the horizontal line test. Is g 1 to 1? Well, it's input-output table, so you can tell that not only is there only one output for each input, there's only one input for each output. So this is a 1 to 1 function. Find a formula for h inverse of x. So here you're going to start with writing y equals 12 over x minus 1, and then get the inverse by changing y to x and x to y. So this will be x equals 12 over y minus 1, and you'll have to do a couple more steps to solve for y. That'll give you the formula for h inverse of x. Let's look at number 7, where you've got these inverses involved. So this is g inverse of f inverse of negative 3. And let's talk about finding inverses from a graph or a table. F inverse of negative 3, that's not f of negative 3, it's the backwards function. It's saying find an output of negative 3 in the f and then locate the input that would go with it. That's what f inverse means. So I would go to the f graph, but instead of starting at x equal negative 3, I'd start at y equal negative 3. Come back and find this point here that's got a second coordinate of negative 3, and work my way back from the y-axis back to the x-axis to see that the x-coordinate of that point would be negative 2. So f inverse of negative 3 is equal to negative 2. And then I'll take that to g. I want to find g inverse of negative 2. Instead of going from the input of negative 2 to the output, I want to find an output of negative 2, there it is, and go backwards to an input of 3. So g inverse of negative 2 is actually 3. Let's see. Let's press ahead. Page 3, you get a couple of specific examples. F of x is 3x minus 6, and g of x is the reciprocal function 1 over x. I'm going to check to see that I'm still, I don't know, it seems like the zoom changes on this. Hope I wasn't getting stuff cut off on the last one. It says find a formula for g inverse of x. Something interesting happens here. Let me go ahead and do this. As a function formula, or as an equation, y equals 1 over x, change it to the inverse. We're talking x equals 1 over y. Then solve for y, and I actually get y equals 1 over x, so that g inverse of x is 1 over x, it has the same formula as g. So g is actually its own inverse. And I think what you know about reciprocals will tell you that's true. You take the reciprocal of a number, then if you take it reciprocal again, you get back to where you started. And they say sketch graphs of g and g inverse. Well, g is your basic reciprocal function, right? I haven't done a fantastic job of this, but it has a graph sort of like that, right? That's g. And now if I reflect over the line y equals x, you'll see that g is actually symmetrical with respect to that line, right? That graph has symmetry across that line, and so it would fold onto itself. So here's an example where a function can be its own inverse. Let's see what else is on this page. Find a formula for f inverse composed with f. Anytime you see compositions, start out with the definition step, f inverse composed with f of x, or f inverse of f of x, and then fill in f of x. So in here, you're gonna, f of x is 3x minus 6, and you're going to input that into the formula for f inverse that you figured out up here at the top of the page. Okay. Something kind of cool about composing a function with its inverse in either direction is you should just get x back, because when you compose a function with its inverse, you just get the identity function. Basically, that's another way of saying inverses undo each other. And then let me look at the very last page, which is actually a review from last week, rational function review. With the test coming up next week, I'm a little bit concerned about the rational function material because I know it's challenging, and I just want to make sure you're prepared for the what will be on the test. So here's an example that in my hybrid sections I give as a quiz. You've got one rational function, and I'm asking you to state the domain. Find the holes, if any. Those will be ordered pairs if you've got any holes. Intercepts, so that would be x and y intercepts as ordered pairs. And equations of any asymptote. So if you have a vertical asymptote at x equals 7, you're going to write x equals 7, the equation for that. So I want you to just go back to that 6-step process for analyzing and graphing rational functions, and see if you can do this without a calculator. For you guys, I don't really object if you can get through this and you want to check with your calculator to see if the graph you're coming up is reasonable. Okay, so that's the activity for this week. I know it's a lot to do, and watch for more information from me about a study guide and review for Test 2.